Okay, so this is chapter 1, lesson 4, ratio tables. We've been trying to answer the essential question of how do you use equivalent rates in the real world. We've probably answered that numerous times over. In recipes, whenever you make something, you have to, bring things up or bring things down depending on the size or the number of people you want to accommodate for. Normally recipes are given in servings of 4, right? So if you needed to do less than 4, you'd bring it down to half and make appropriate servings. Okay? The less than essential question is how can you determine if two ratios are equivalent? Okay? What we had in class the other day was we could use math and put it in its simplest form, and then you can tell if at that point in time you should be able to tell if two ratios are equivalent. All right? If you don't need a black and red dry erase marker. You could use a black pencil and a red pencil or something of the sort, even a blue pen and a pencil. Okay, we're just going to try this little exercise. It's in your book. Right? It says a punch recipe uses 1 container of soda and 3 containers of juice to make a batch of punch. All right, and it says so we need to have 1 soda, and 3 juice. Okay, it says draw red counters to show the number of containers of soda and draw yellow counters to show the number of containers of juice. Needed to make 2 batches of punch, right? So it's like 2 soda, we have 1 for each batch, and then we need 2 sets of 3. Sorry about that. 2 sets of 3 black dots to show the juice. So then we have 2 soda, keeping it in the theme of the color, and 6 juice. And when you reduce this, it's obvious that it reduces down to 1 and 3, right? I mean, you can see that. So again, as I spoke to you before about recipes, when you make a recipe, you may have to double the size or even just bring it up by 1. Now this one is the same idea, but it says to use 3 batches of punch. So we would use 1 times 3 for soda would be 3. 1, 2, 3. And then 3 times 3 would be 9 for the juice. 2, 3, 1, 2, 3. Okay, and then you would have 3 soda, 9 juice, right? Okay, not too hard. You should be able to do all this stuff on your own. What I suggest that you do is you try this stuff. As I get to these examples over here that I do for you guys, you should try to do those on your own before I start doing them to see if you're understanding it. And then I would take maybe notes on just the example, the way I do my notes, right? Okay. Equivalent ratios. The quantities in the opening activity can be organized into a table. This table is called a ratio table, okay? Because the columns are filled with pairs of numbers that have the same ratio, okay? The ratio 1/3, 2/6, and 3/9 are equivalent, okay? Since each simplifies to a ratio of 1/3. Remember we talked about that? Simplifying it. And you would find out, so we've answered both our main essential question, and we've already answered the less than essential question. You should be looking at that stuff to understand what it is that we're trying to learn. That's what those essential questions are there for. Okay, equivalent ratios express the same relationship between quantities. Okay, it's a 1-to-3. For soda to juice, it's a 1-to-3 ratio. 1 soda for every 3 juice. Or the other way around, 3 juice for every 1 soda. Okay, it's an example. Okay, try this on your own. See if you can do this on your own. To make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. I know the answer's there. Try to do it without the answer. How much yellow food coloring should you mix with 5 cups of white icing? Okay, the ratio is what? 6 to 1. They want to know what happens if you got 5. This is white icing. This is yellow food dye in drops. Right? This one's in cups. You should label this stuff properly so that you know what you're looking at. This is in drops. Something unusual, I know, but it does happen. Okay? How did you get 1 to 5? Well, you multiplied by 5, right? So do the same on the bottom. On the top. 6 times 5. 30. Okay, not too hard. Should not be too hard. Okay. See if we're right. There we go. See how nice we did that? Use the ratio table. Since 1 times 5 equals 5, multiply each quantity by 5. So add 30 drops of yellow food icing to 5 cups of icing. Okay? Now, the next one, they do a two-step process. I wouldn't do a two-step process. That's just making life more difficult for you. I would try to keep it in one-step processes. But if you don't understand it, that's fine. You can divide by whatever number to get it down small enough. Okay? In a recent year, Mr. Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. Okay? That's okay. So we set up our box real quick. We ate 66 hot dogs in 12 minutes, right? If he ate at a consistent rate, determine about how many hot dogs he ate every 2 minutes. So we're trying to get the number of the number of minutes down to 2. Trying to get minutes down to 2. Okay? How did you get 12 down to 2? We divided by 6, right? Okay? You divide this by 6 over here. You get 11. So you ate 11 hot dogs in about 2 minutes, every 2 minutes. Okay? Now, you can just divide each quantity by one or more common factors until you reach a quantity of 2 minutes. Okay, that's why they give you the extra box. See, here they divided by 2 and then they divided by 3. Because maybe you won't see that right away. Now, I happen to see it right away, and you probably should too. Okay, you should be able to tell me, what divided by 12 divided by what would give you 2. You should be able to answer that pretty easily. Okay, but if not, just do a two-step process. Okay, let's try these in our notes. Okay, the patient receives 1 liter of IV fluids every 8 hours. At that rate, how many hours would it take to receive 4 liters of IV fluid? As you can see, from here to here, they multiplied by 4. 1 times what equals 4? 4, okay? So whatever you do to one, you do to the other. So 8 times 4 equals 32 hours. Takes a long time, okay? To make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. Find the amount of sugar needed for 4 cups of cranberries. Okay? What did they do to 16 to get it down to 4? Okay? They divided. It's got to be multiplication or divide. Okay? What times 4 equals 4? 4 times 4 equals 4. 4 times 4 equals 16, so 16 divided by 4 equals 4. Whatever you do to one, you do to the other. Okay? Now, if you wanted to take many steps, right, you could have divided by 2 at first. Got it down to 8. So you'd have to divide this by 2. Got it down to 6. And then you could probably, you see that you can divide by another 2 since they're both odd still. They're both even still. But this is the same thing, right? It's okay if you take 2 steps. All right? All right. Use scaling. Multiplying or dividing 2 related quantities by the same number is called scaling. We've been doing this already, so this is just the terminology for what we were just doing. Sometimes you may need to scale back and then scale forward to find an equivalent ratio. Okay, so now we're not just going to simply divide or multiply to get our answer. We're going to have to do both. Example. Cans of corn are on sale at 10 for $4. Find the cost of 15 cans. Okay? What did they do? So, okay, we can't go directly because there is no number that you can multiply 10 by. Here, I'll show you what they say here, because this is going to say exactly what I want to say. There is no whole number by which you can multiply 10 to get to 15, so scale back to 5 and then scale forward to 15. Okay, if you can't realize that 5 is a common factor between 10 and 15, you need to break them down and check it out and find out one of the common factors, not necessarily the greatest common factor. Yeah, necessarily the greatest common factor. You find the greatest common factor between those two, and you put that here. Okay? So you'd break apart 10 and 15, right? This is 2. 2 times what equals 10? Is 5. Okay, then over here we do the same thing. 3 times 5. And we realize that 5 is the greatest common factor, which is the reason why it's put here. Okay? So what do you have to do to 10 to get it down to 5, you have to divide by 2. Okay? And then you can easily see that you need to multiply by 3 to get it back up there. Whatever you do to the top, just do to the bottom. Okay? You divide it by 2, which gives you 2. And then you multiply by 3, which gets you 6. Okay? It's not that hard. It's really not that hard. Don't let all this stuff overwhelm you. Okay? It's a lot of work, but this is where all your hard work has been. You've been working on all that multiplying and dividing to be able to do stuff like this. Okay? They show it here that we're correct. Divide each quantity by a common factor of 2. Okay? Again, I wouldn't call it divide each quantity by a common factor of 2. I mean, I guess so, since they both 10 and 4 have 2 in alike, but I wouldn't have done that. What I would have done is found the greatest common factor and put that in the middle. Okay, just like I did. And then you have to figure out how you get 10 to look like 5, and then figure out how to get 5 to look like 15 through division and multiplication. And it gives you a little more to think about. Okay, because sometimes, I mean, they set it up so that it works, but I don't know. Okay, so 15 cans of corn will cost $6. All right, here we go again. Let's try another one. Okay, Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? Okay, let's go ahead and just, we'll keep this covered. Is there a whole number by which you can multiply 14 by to get 49? I'm going to tell you right now, no. Okay, because this, since 14 is an even number, it's never going to get to an odd. You can't multiply an even number by you can't just multiply even numbers and it become an odd number, because it don't work. Any number multiplied by an even number stays even. Okay? It's just a rule. So, you need to scale back to what? So you got to figure out what 14 and 49 have in common. Okay? This is 2 times 7. The greatest common factor between these two numbers is 7. So you got to scale back to 7 and then scale forward to 49. Okay? So you scale back to 7 by dividing by 2. Whatever you do to the top, do to the bottom. Okay? And then you got to scale back up from 7 to 49 by multiplying by 7. Whatever you do to the top, you do to the bottom. It's very simple. Okay? Here we go. All right. We need to find the greatest common factor right here. Okay? So you take 25, you take 105. I mean, most of you can probably see what it is immediately, because there's only 2 factors over here. It's obviously got to be one of these two, because you cannot multiply 25 by something to get it to 105, whole number wise. 4 gets you to 100, 5 gets you to 125. Okay, so it doesn't work. So over here, we need to break this down a little bit. I only see a 5 to be brought out of here. 5 times 21, okay? And then 5 times 3 times 7. I would have never seen a 3. I didn't see a 3 when I first looked at it. So I instantly would have pulled out a 5. Okay? Then you got to circle what they have in common. Right? So 5 is the greatest common factor, so you put 5 in here. And then what you do is you scale back. Okay? You divide 25 by 5. You know, it's right over here if you don't recognize it. And then you got to multiply 5 by, look, we've got it already written, 21, to get it to 105. Whatever you do to the top, you do to the bottom. 10 divided by 5 is 2. And then 2 times whatever we did to the top, we do to the bottom. 21 is 42. Okay? Simple. All right, try this one on your own. And then I'm going to give you a few seconds to pause my video. Pause my video. Do this one on your own. Set it up. Try to do it. If you're confused, start the video back up and I'll at least set up the problem. Okay, if you're looking now to just set up the problem, here I'll set up the problem for you. It says, on her vacation, Leah exchanged $50 American and received $60 Canadian. Use a ratio table to find out how many Canadian dollars she would receive for 20 American. Okay, so we set up the ratio. It says Canadian dollars is 60 and American dollars is 50. and they want to find out what it is you'd receive for 20 American dollars. All right, that's the setup. Why don't you go ahead and pause it again and continue on from there to see if you can do it. Remember, you're trying to find greatest common factors. Okay, we're now going to try to find the greatest common factor between 50 and 20. Okay, we're going to divide by 5 here. I can see that works, and that's times 10. And I'm going to bring this 5 down, bring this down here. This is 2, this is 5. Okay, then over here at the 20, I'm going to go, what, 2 times 10, which is the same thing as 2 times 5. They have actually 2 numbers in common, right? They have 2 and 5. All right, so 2 times 5 is 10. Okay, and now you can work from there. How do you get 50 to look like 10? Well, you just divide by 5, right? Whatever you do to one, do to the other. So here we're going to divide by 5. Okay, 60 divided by 5 is 12. Okay, do the work if you don't know it. Okay, then we get 10 to look like 20 by multiplying by 2. Whatever you do to the bottom, do to the top. 24. So you get 24 Canadian dollars at this time for 10 American dollars whenever this was written. You know, I'm sure that's not true anymore. All right, so you start the guided practice. Once you're done doing that, show me what you did, or prove it to yourself. When my new class comes, what you're going to do is you're going to be showing me the guide that you can do what you can do by doing the guided practice, and then I'll let you go to work on your homework. All right, the homework is extra practice page 45, 46.